Okay, great. There we go. All right. Today, as you probably guessed, we have another activity. Right? We're so excited about that, right? But it's not bingo, and unfortunately, it's not a murder mystery. But we are going to play Jeopardy. But before we do, guys,
Is it like a cool Jeopardy?
it is a cool one because I made it. Thank you. Not as cool as that sweater. Guys, I made it. Great. But before we do, we're going to introduce ourselves to discriminants and square roots. And please, put the phone away. And the earbuds, Gino. All right? So, we are going to review the quadratics because we're going to need this to play Jeopardy. We want to win, right? And the quadratic formula. We're going to, I'm kidding. Is that what happened to the football team?
Oh, that's like you.
An introduction to the discriminant.
I will get you.
Got it there. He walked in. Right? So we're going to introduce ourselves to the discriminant, find out what it does. Then we're going to take Robert some more roots 5 factor 2.0, and finally we're going to be playing this Jeopardy game. I seem like I'm racing a little bit. It's so much fun. I want to make sure I maximize our Jeopardy time. And then we're going to have a conclusion and a very, very brief exit session. Okay? So Ryan's already looking at it. He was with me with Jeopardy. He didn't like the exit session. But don't worry, it's small. So don't worry. All right. So what I want you guys to do now, don't worry about 3 because it's for the sort of smaller class. You guys 3, you 2. So groups of 3 and 2 are fine. So Maya, you're like the swing vote. You can go with them. You can go. You're right here, the swing vote. You can go this way, that way. You guys 2 groups of 2, and Robert, I'll just throw you in here with all this one group right here. Okay?
This is my group.
Yeah, there you go. Now I want you in your group. Get out a piece of paper. You're going to go over 3 things you know about quadratics. Adama, do you have a piece of paper? I've got extra if you guys don't have it.
Can I have a piece of paper?
Absolutely.
Thank you, sir.
Can I have one too?
Absolutely. Got extra sheets right here. You need sheets right here. Robert, you need one? And Jack, where's Jack? Of course, Jack.
Do I have some AC in this line, though?
Not yet. You gotta do this activity.
You got a pen?
Yeah, I get you one. Thank you, William. All right. Let's see. I'll get you something, Jack. Let's see what I got here for you. Now, I want you each to write here. Take 1 minute by yourself. Notice I underlined self there. You're going to write 3 things you know about either the quadratics in general or the quadratic formula. All right? Take a minute to do this. Now, the reason we're doing this is because we had a test on Friday. Can you believe it? You believe
and then we have a test on Monday.
On Friday. Then Friday. That's only like 4 days from now. So we have time. We got to prepare, right? So I want to make sure that you guys have a really solid foundation in these 2 areas because it's going to be a big part, right, of what we're doing on Friday. So write that down. You're going to start your minute right now.
I don't even know what the bug is called. Oh, that's what it is.
Okay, guys. You only have 1. I'm calling on you first. Big eye. Now. "15 seconds. I'm going to move on to the next. Share this with our group before we share with the class. All right, gang. Now, in your team, you guys are 2 or 3, right? Within your team, I guess we're going this way, right? I want you to share your list with them, right? And I want you to have at least 5. You should have 3. Combined with a couple other people, you should be able to get to 5. I'm going to start calling on teams. here in just a second. We're going to share with the rest of the class. So I want you to take a minute, talk amongst yourselves, get that list, bump that thing up to 5.
I feel like I'm missing a part because
Alright.
No, I don't like that. I like the build-up.
Oh yeah.
Okay, so like if you most of the time you're gonna get to equations, sometimes
I know.
you know what Caroline said? He said,
Share in here.
like your little something and stuff like
What else do you know about a quadratic?
that. Like it's gonna be 2 equations, but it's not always gonna be 2 equations. I'm studying. You're also skinny, and you're also sexy and witty.
This. So we can move on.
Oh, wait. Oh, that's so sweet. Oh, thank you.
Yeah.
I am sweet though. Well, like,
Do you start in
I just had one game, and I didn't start, and I was lost the first one. Did that? How many years the last game?
Can, yeah.
Right now?
Starting for my suck, and just like in practice, but then in the game, I scored more points than the starters. I did. Michaela, you don't suck at practice, you suck.
Michaela, in 8 seconds.
I am
Imaginary
so
numbers in the
great. Why do we
class.
have the same, like,
All right.
capacity?
All right, guys. As I promised Michaela, when called upon, Adama, you're going to read one thing from your list.
One thing for my list
Yes.
is that I said that usually when you solve the quadratic equation, you're going to get 2 equations, but you're not always going to get 2 equations.
I'm going to call that. That's awesome. That's awesome. So what Adama said is I'm going to just change equations to roots.
Mm-hmm.
So when I solve a quadratic equation, what do you mean by solve?
Was when you go through and you plug in all the numbers.
So we set the quadratic equal to what value?
0.
Perfect. When we set it to 0, Adama's dead on, right? When we solve a quadratic, and I'm just going to write set equal to 0 right here. Set equal to 0. We get 2, right? 2 solutions. Right? And even though sometimes we're going to see we only have one distinct one, it has what's called multiplicity 2. It means it just happens twice. This is 1 point. So generally, I'll put generally here for that. We generally get 2 solutions. I love the way you said that. Now it's Michaela's turn.
Can I go to the bathroom?
And you can generally get, after we go through all this, you can. So
if you need to.
go ahead. Give me your.
If you need to. The vertex form is negative b over 2a.
Well, that's not the vertex form. That's actually the x-coordinate of the vertex, but that was awesome. Negative b over 2a, right? That was awesome. Awesome. So that's your team. What team are you? 2?
Wait, that's the vertex?
That's where the vertex is on a standard form. 2
Yeah, that's
and you're 3, so you guys are together. 2, 3, and are you 4? I'll just go right here. One of you guys. Ryan, you're right in the center. So
Wait, Michaela,
you can ask
my
around.
group.
Give me something from your list.
The quadratic.
Awesome. Tell me what it is.
Negative b plus or minus square root of b squared plus 4ac.
Minus 4ac over what?
2a.
That's awesome. I'll take that any day of the week. You guys have anything to add?
What did that say? Solve?
What do you got? That's awesome. I mean, be proud of that answer. That's awesome, right, Ephraim? Ephraim, I'm taking that one. This is Ephraim. Ephraim, thank you. Right, Ephraim, that's awesome. I love that answer. And what he said was, listen, I can use the quadratic formula if it's not easily factored, right? Because it always gives me a solution. That's awesome. Quadratic formula always gives solutions. I mean, I'd be proud. That's as good as it gets in terms of answers. All right, we're going to go with my back 4. Somebody in my team here, give me something that's not up here.
There's a solution.
What's the solution?
I mean, it's a formula.
What is? Well, okay, let's go with another one, though. It's not quite so obvious. Dalen, what do you got? I couldn't have said it better. Now, what kind of form? Johnny, that's awesome. Standard form, as Dalen just said, and trying to help, right? Standard form is equal to this. So y equals ax squared plus bx plus c. That's awesome. Now in this case, the x squared is the quadratic term, the bx is a linear term, and the c is just a constant. That was awesome. Now we're over here. What do you got?
Whatever you plug into b minus is the opposite.
Whatever I plug in, right, over here, it's going to be the opposite of that b, right? That's a good job. That's a good job. Lauren, what do you got?
Normally you plug in numbers from standard formula.
All right, so I'm going to put that right in. Both of you right there are saying the same thing. Plug in values of A, B, C into quadratic formula, right? That's pretty awesome. China, you got anything else?
Nope.
That's all right. Gregory, what do you got? You got anything we haven't talked about? I love it. That's just a square is any square. I love it. Because we're going to be talking about that. I squared equals -1, Gregory. That's awesome. That's awesome. Dom, you were great that first time around. You got anything else that we haven't?
No, I don't really have anything else.
Well, we talked about, just to make sure, we were there, we talked about the standard form. Is there another form, Jack? Since you're laughing, is there another form?
No.
There isn't? Gina,
Vertex is the
tell me.
That's what I
Tell me what you said. What is it?
the vertex.
Vertex form. And what does that look like?
Thank you.
All right, so in the vertex form, you guys remember, right? We've got some sort of vertex form, right? So we're going to have x minus some value, whatever it is, right? So I'm going to put x squared is going to equal some other value, right? And this is where our vertex is, x minus c squared, whatever that is, right? Remember that? All right, and then we're going to have some sort of x minus c squared is equal to, and I'll just put these, right? It doesn't really matter. This is where my vertex is going to be, right? So anyway, yes.
Are we done?
Yes, I think we're just about done. So you know everything up here?
Yes.
All right. Do you guys follow everything primarily? Right. We've got standard vertex form. Right. Standard form is the one we're going to be working with. Right. Ax squared plus bx plus c.
So that's x minus c. Okay.
Yeah. But really, you put -0. It doesn't really matter.
Is that b squared?
Yeah, sure. You can use any number. Okay. But the point is that that's what the vertex is going to be. So you can put it up your square. So the standard form here, right, is the one we're going to use the A, B, and C into the quadratic formula. That's what we're playing Jeopardy. That's what we're going to do here in a second, right? We're going to use that. The quadratic formula always gives us nice little solutions. We're going to see they kind of differentiate, right, depending on a couple values that we're going to see. But if I can't factor it, I can always go, right, to a quadratic formula. The only other thing I might say, right, let me move this over here. I might say, if you guys remembered this, I should say, sorry, x squared minus a squared is equal to x plus a times x minus a. You guys remember that? What is that in our toolbox? Yeah, we're factoring. We're going to talk about that today. But it is right, the highest power. That's what a quadratic is, right? The highest power is 2. No. Highest order power of a quadratic, because quadratic means square, which means 2, right? Yeah. So you're absolutely almost right here, right? It's a difference of squares. Yeah. Right. So if you guys know this stuff here, you guys are really gonna, that's a good start on Friday's test. I'd make sure I know this. So I'm gonna keep it up just for a little bit, and we're gonna move on, right, to our first sort of activity. Any questions? All right. You take a picture, write it down. Know these things, and I think you're gonna take a step forward. All right. Quadratic formula. Einstein once said it's all about the quadratic. Do you think he said that? I made that up just to be cute, right? But it's cute, right? So it's all about, but it really is, right? I mean, you're going to see a lot of things, Robert. I'll tell you what I think. You're going to see a lot, as you go in your mathematical and scholarly careers, a lot of relationships are defined by the square. Something is proportional to the square of something else. You're going to see that a lot. And I mean, just think about it in terms of acceleration, right? T squared with respect to just position. There's one right there when you guys get into physics. You're going to see that a lot. So It's very important, right? The quadratic formula is very, very, very important. So, you guys, I say group, but not quite like the last one. You guys are going to be on my right. I need another team on my right, so you team are going to be on my right. You guys are my center, and you're my left. You guys on the right, I want you to solve this problem. 3x squared minus 8, that's back row, and you guys right here. 3x squared minus 8x plus 5. You guys are my center. I want my center to do this problem. I want each of you to work on it. If you got any problem, then talk to your neighbor, left or right on your team. And over on the left, I want you to solve that one. You're fine.
Number 1.
Yes.
Oh my goodness. Yeah.
Kim. Yes. That's minus 4. One more minute. Jack, coming out there. I'm gonna come again.
You sound sick again.
Me? Yeah.
64 minus.
I just don't know.
Please, I can't do that. If it's negative, so would I use the I?
I wish I could.
About 30 seconds, and then we're going to go over these.
Wait, yeah, I can't.
I don't know how to do that.
And then 8 minus 2 is 6. And then it's 12 and 8. So, you're only supposed to do 1. Oh, it's supposed to do 1? Yeah.
Wow.
Okay, Gino. We're going to be going back into it, Jack, in a second. All right, guys, so what we're going to do The guys on the right, you're part of the right, Gino? All right, get me started over here. Problem 1, Gino, which one is A? I'm coming. Three. A, good job. So A is 3. What's B? That's nice. And C?
5.
That's really good. All right. So I'm going to put right here. So what do we have here? 3x squared minus 8x plus 5. Jack, set up the quadratic formula for me here.
Alright, so we got negative b.
All right, so hold on. X equals negative. Now what's B?
8x.
So negative 8, right?
Yeah.
Keep going.
Plus or minus.
You got it.
Square root.
Yep.
Of 8 squared.
So negative 8 squared. It won't matter.
Negative 8 squared.
It won't matter. Go ahead.
Minus.
Yep.
4.
Yep.
3.
Yep.
5.
You got it. Okay. Over.
Two.
Good job, though. Keep going.
Good job.
Keep going. We'll go to him in a second. Go ahead.
2.
2.
Three.
Yep. All right, Robert.
No,
Help me out.
me.
Robert, what's negative times negative 8? What's negative times negative 8?
Say what's what?
Negative times negative 8. Negative of negative 8.
8.
You got it. Nice job. All right. Now what's 8 squared?
64.
You're on a roll.
I messed up.
So 4 times 3
12.
times 5.
Wait.
You're on fire. Times 60 and 2 times 3. All right. Now we're off to Michaela land here. All right, Michaela. You can just look up here.
Negative 8.
So I got 8 because I had, right? So I have 8 plus or minus. What's 64 minus 60? Awesome, so I'll just go right there. Go to the source over 6. All right, so Maya, what can I do here?
Ooh.
What's the square root of 4? Alex is a nice guy. Okay. So he says it's plus or minus 2 over 6, or so I can say, well, I'm going to do that. I don't want to use the word yet. X equals 8 plus 2 over 6, right? And what's that? That's good. Yeah, 5 could be 10/6 or 5/3. Or, go ahead. But if I take 8 minus 2, right? What do I get? What's 8 minus 2?
6.
Over 6 equals what?
1.
You got it. So you've got an answer of 5/3 or x equals 1. Yes.
So
I thought it was negative 8.
It's negative, right,
But
of
it's
negative
not.
8. And as Robert so eloquently told us, that negative of negative 8 makes it positive 8, right?
Oh, Michaela, keep up. I'm being dangled on the red.
All right, so my answers, right, are x equals 5/3 or x equals 1. Now, let's go to my center teams, which are right here. And Anna
Yes.
is going to tell us what's A.
Woo! Yeah. 5.
All right, here's A. What's B?
Anna,
What's B?
Oh, sorry. X. Negative X. I mean, negative 8.
Negative 8 is
Oh,
B.
my God.
And what's C?
5.
All right, nice job. Nice job. All right, so now this one, we're going to do right over here. There we go. Okay, so we're going to go through, we did already here, so we'll start with over here. Gregory, set up the quadratic formula for me. So what'd you do there? You said the same thing we did over there? Right? Negative of negative 8. All right, cool. Keep going. Plus or minus, right? Of negative 8 squared. It's going to be the same thing. Yep. Minus what?
Minus 4 times.
Awesome. And is that what's that over? All right, Christina. Let's keep it going. Let's simplify this. What do you have here? 8. Awesome. 64. 100 over 10. We go along the lines. Okay, Sarita, what'd you get? What's that? Yes. All you have to do, I'll tell you what, is to tell me what's 64 minus 100. Negative 36 over 10. Well, we got a bit of a problem, Ephraim. Ephraim. What do we do here? I've got minus 36. Can I take the square root of minus 36? That's right. Right, you're doing this one. Can I do that? Minus 36? What can I do here? Oh my, wow. That's amazing. So you're saying you can use your imagination. Because I can't multiply two values, right, to get a negative number. But Grady said, well, wait. You can write that as the square root of 36 times what? Well, that's true, but I'm going to get, yeah, that's right. But 36, this 36, what? Negative 36 is equal to, exactly, is equal to 36 times negative 1. Yes? We're going to get to that right here, right? Over 10. Now, what is the square root of negative 1? Ready?
1. Oh, sorry.
Go ahead, Frank. What is that? Square root of negative 1. What does that equal? No, we're using our I. So this is I. Right? Right, Norman, this I? Okay, so I can rewrite that as x equals 8 plus or minus the square root of 36 times I over 10. What's the square root of 36? John. Give me up. 6? Awesome. So this becomes 8 plus or minus 6I over 10. Now, is there a greatest common factor among all those? 8, 6, and 10?
2.
Nice, right? I can pull out 2, right? So it's 4 plus or minus 3I over 5, right?
Wait, Mr. William?
Yes.
Square root of 36 times square root of negative 1 is what?
This is I, so it's the square root of 36 times I. Sorry.
So, what's the answer?
Right here.
That was only one answer?
No, good question, Dom. Notice there's a plus and a minus, right? When I see the plus minus, I have 2 answers.
So we didn't solve it yet?
No, I mean you did, that's it.
So those 2 are the answers?
Yeah, because you can't combine 4 and 3I because they're not like terms, right?
No.
So we'll write it like this, right?
I'm so confused.
That's all right. Let's go back over here for a second. How many answers did I get here?
2.
And were they imaginary or real?
Real.
So I have 2 real roots here. Let's go over here. I have 4 plus 3I over 5, and I have 4 minus 3I over 5. I could write that as 2 answers, but we generally write it shorthand like this to express that.
Okay, so 8 plus 36.
The square root of 36 is
and then
6, right?
okay, then 36.
Yeah.
Actually, what's the 3?
Oh, yeah. So I ran out of room, but Anna said you can pull a 2 out from there, so that's 4 plus or minus 3I over 2 times 5. And I just, right? Because I asked what the greatest common factor of 8, 6, and 10 was, and Anna said 2.
Yep.
You can pull a 2 out. So that's all I did there. So how many roots do I have here? Someone from up in Adama's team here? How many roots do I have here? 2, right? Because I got the plus or the minus. Guys, if you see a plus or a minus, you get 2. And Ryan, what kind of roots are these? I mean, look at the number. 4 plus, is it like this one over here?
Oh, yeah.
Are they not real? What are they over there? They're imaginary. I'll call them complex and imaginary. So I'll just say 2. I like that. So we're just going to put 2 imaginary. All right? Roots. Nice job, Ryan. All right? Now we're going to go over to team. What is this team over here? You guys are 1?
Yep.
We'll start with Lauren and work our way around. Lauren, what's A? Nice. What's B? Nice. What's C? 1. Okay, Uthman. Let's remember the quadratic formula, my friend? Remember the quadratic formula? All right, help me out. We're going to do yours right here in the center because you guys are important. Pay attention, guys. Here we go. All right, what is B?
What's an exit?
Lauren, your teammate just told you. 6. All right, x is -6 plus or minus what? You got it. 6 squared minus what? Times,
You said it's six.
which is
No, what's
9, times what?
Oh, I thought you were
1, right? Because we got 1. And that's over what? Make sure you ask your teammate here. 2 times what? What's it over? 2 times 9. So China, help me simplify this, guys. Hold on, guys. Go ahead. Hold on. Go. 36. What's 9 times 4? 36 here too? Oh, okay. And we get 2 times 9 is what? 18? All right, guys. Hold on.
How come
So-
they got easier problems than us?
It is different type.
Give me
Come here. What's the 36 minus 36? 0. Brian, what's the square root of 0? So I got -6 plus or minus 0 over 18. What's that? -6 over 18 or what? Some kind of good stuff. You got it. -1/3, right? That's what that is. So, all right, back here, Jack. How many answers did we get?
We got 2.
Did we?
No, we got 1.
What kind of one answer did we get?
A fraction.
No, what type is it? Is it, if these are real and those are imaginary, what is it?
That is real.
Real. We got one real solution. All right, we got 2 real roots here. Yes, sir. Not yet. One chance. We got 2 imaginary roots over here. What gives? Michaela, what's the difference? I don't understand. I ended up with real over here with you guys. You guys ended up with imaginary numbers, right? As Adama said, they were the hard ones, right? And you guys ended up with just 1 root. What was the difference? I don't know, Brian, you see the difference? You raising your hand? The imaginary number, where'd that come from? Guys, in the center, where'd that imaginary number come from? What makes an imaginary number? A negative what? What's negative in an imaginary number? The square root. Thank you, Lauren, was negative. Galen, does that give you an imaginary number? You got the square root of negative? What part, Gino, take out your earphones, please. Gino, tell me what part of the quadratic formula is a square root? Show me. What is it?
The b squared minus
4ac. So wait, you said the square root's a negative. He said it's b squared minus 4ac. So what are we saying? If we get an imaginary root and we get a negative square root, and you said, wait, the only thing under the square root sign was a b squared minus 4ac. Almost. Punchline's coming. What do you mean by that? So what are we saying? Over here, then what? Since I had imaginary, what had to be negative? Under the square root, which was what? Just say it again. What did you say before? What's under the square root in the quadratic formula?
b minus
B squared.
Because you were listening to them.
So that had to be negative according to you. So, Gina, b squared minus 4ac being negative, Adama gives us what? A negative square root. And what kind of solutions do we have?
Oh, the one that you would have to give an I.
Yes! Awesome. So, what you just said is that if b squared minus 4ac is less than 0, I get 2 imaginary roots.
Okay.
What about over here?
Real numbers.
And how did that end up being a real number?
Because you don't have a negative.
I don't have a negative. But how many solutions did I have?
2.
How did I end up with 2? I only had 1 over there. Why is this
You
2?
said you
No,
had
no,
2.
this.
Oh.
This has 1 real solution. What's the difference?
It has real numbers.
Well, they both have real numbers. What's the difference?
It has no I.
No. Well, the b squared minus 4ac, yes.
greater than 0.
It's greater than 0. Over here, b squared minus 4ac is greater than 0. And what about here? Over here, what'd you get for b squared minus 4ac? 0. b squared minus 4ac.
So that means you only get one answer?
That's right. It's equal to 0. So the answer, or the type of answers, is wholly dependent on the value, Jack, of b squared minus 4ac. And it is so powerful, that b squared, right? You like that, huh?
Yeah.
It's so powerful, we have a name for it. It's called a discriminant. A discriminator. Now tell me, somebody in this room recognizes that.
I recognize the Terminator.
Thank you.
That's what I call it.
Okay, you bonus points. The Terminator. So the discriminator. We're talking about. And guess what, Robert? Hey, Robert, we're over here, big guy. Look.
Oh, he called
It's,
me big
yes, b squared minus 4ac is known as the discriminant. Is this going to be on your test, Brian, on Friday?
Yes.
Oh, you better believe it. 1,000% chance, right, that this is going to be on your test. b squared minus 4ac, Alex, is the discriminant. Dictionary.com defines discriminant as something that makes a distinction in or between, i.e. differentiates.
Is
That's
that
why
B
they call it a discriminant. What's that?
Is that b squared?
Oh, sorry, b squared, yeah. b squared minus 4ac. So, the discriminant, as you guys determined, a little help. Gina, we did great, right? A little help here. We got there. Right? Madama, Gina, Lauren helped, right? We all got there. We said that the value of b squared minus 4ac, that is the discriminant, will determine whether I have two real roots, two imaginary roots, or just one root. Whether it's positive, negative, or 0. The whole solution, right, is determined by that. The roots, right, of the quadratic, the roots that you get from the quadratic formula are entirely determined, the types anyway, by that discriminant. Okay? And here is a little slide. And I kind of show this to you of our problems. Notice, before I do that, notice that if the discriminant, which they call d, is less than 0, notice it's up here. Here's the x-axis. Notice if there's one real root, right, our variable is there, and two distinct real roots. Now, when I'm looking at this graph, Robert, where are those roots on that graph?
Why are you asking me?
Just take a look. I've got one here, I've got two here. What do we call those? Ryan, help him out.
What, on the x-axis?
Yeah, what do we call it?
X-intercept.
X-intercepts. I get bonus points on wood, right? That's awesome answer. X-intercepts. The solution are where y equals 0, right? That's what we were trying to download, right? You said it equals 0. Those are the x-intercepts. Robert, notice that for the imaginary, that is when it's less than 0, is it touching the x-axis? No. You got no real roots. When the discriminant is equal to 0, notice it touches once. And notice that it intercepts twice when we got two real roots.
Wait, let me give a picture of this.
Oh, you're going to? Yeah, get a second. I'm going to show you our graphs. All right? Hold on. I'm going to show you our graphs. There we go. About that one. How about that one? Here are our graphs. Take a look. This was the one you guys did, Lauren. Notice where it touches. You guys on the right, Michaela, saw this one. Notice at 1 and 5/3. 1 and 5/3, right? So yours over here says, oh, that's about like negative 2/3.
Oh, there's on the back point.
Another negative 2/3. And this one, that's yours. Notice it doesn't intercept. So Jack.
So what is that answer over there?
That's this guy right here.
Yeah, so it didn't intersect at all?
Right. So we have to use imaginary. We use imaginary numbers to find that. That's another lesson for a different day. But right now we know that in the real plane there are no x-intercepts if I have just imaginary solutions. All right. Let's go back to our guy here. All right. Back to it. All right. Yeah, go ahead. We got that. That was the key right there. Now, we're gonna change topics because, like I said, yeah, go ahead. Hurry back. Because, Jack, we're gonna change topics because we've got, yes, Shakespeare once said to factor or not to factor, whether it is to nobler to factor or not to factor. Didn't you say that?
Classic will.
Are you sure? Maybe I'm wrong there, but okay. Anyway, we're going to go through this through a couple factoring exercises so we can learn a couple new skills to make sure we're ready for Jeopardy, Robert. All right. Now, same thing as before. You guys are my right teams. Michaela reaching over the aisle. Let me bipartisanship here. You guys are my right. You guys are my center. On the right, that's you. I want you to solve this one. X squared minus 10x equals 11. In the center, I want you to do this one. X squared equals 9x. And over here on the left, x squared equals 81.
What is it?
I think you guys can handle that, right? X squared equals 81. You guys? What's that? Jack, which you're on here. So you over here, Jack. X squared minus 10x equals 11. Take a minute, yes.
Is it 3?
I'm going to come to you. You guys are a little fast. All right. Is he sleeping, Elvis?
Not good.
All right, yes. As long as he stays. Well, what would you do? Tell me what you think you might do. I can promise you that a problem like this, in fact, I got it. I got these problems from the type of problems you're going to see on the exam. So I make sure I know what I'm doing. All right. Team number, what are you, 2, 3?
Team 3.
Team 3, Robert? All right. And Jack, you're on the right, so Elvis is going to help us out.
I like that one.
What's the first thing I can do here? What would you do? Oh, sorry. What was the first thing you did?
Okay, for the first one?
Yeah.
Okay,
Ask Jack, 'cause Jack knows. What's the first thing you do?
Got it.
Dan, can you tell them what the standard form, the quadratic looks like? What's that? Okay, awesome, awesome. So, we're going to erase this over here. And we're going to write what Dalen just said. AX. Love it. Okay, say that again.
AX squared plus BX plus C.
AX squared plus BX plus C. I like that. Equals, and we said that we're looking for a solution. What do we set it equal to? 0. Well, wait a minute, Dalen. That's not quite in that form, and the one you probably got on the exam isn't also going to be in that form. Right? So what would you do, Jack? Help me out.
You plug in.
How can I plug in?
Huh?
Dalen said I'm not in the form yet.
Are you not in the form yet?
How can I get it to be a standard form?
You gotta use that formula AX squared.
Well, how do I get it to look like that?
Plus 10x.
Ah, yeah, Alex says, hey, you know what? I'm pretty darn close as it is. Right? Alex says, wait, I'm x squared minus 10x equals 11. I'm really close to what you said, Dalen, aren't I? What can I do, Dalen, to make it exact? Well, I've got the constant term on the other side, right?
Oh.
Yeah, what if I subtract 11 from both sides?
Done.
So this goes to 0, right? Right, minus 11 equals 0. What do you think, Samaya? Yeah, you could do that, right? All right, Michaela, what do I do next?
Alright, so plug in your little thing, you know, find A. A is 1.
All right, she says A is 1.
B is -10.
B is -10.
C is -11.
All right, C is -11. What is my little thing?
Your little thing is the formula.
What is it?
So 10 plus or minus.
What kind of 10? Just 10? Just straightforward?
Positive 10.
Oh, because it's negative of negative 10. Okay, plus or minus, go ahead.
10 plus or minus the square root.
Hold on, guys, go ahead. 10 squared?
No, 10, -10 squared.
Sure.
Minus 4, and then in parentheses, -11.
Yep.
It's just 1, so it's like
Okay, great.
over 2.
Over 2. That's great. So I get what? 10 plus or minus, you get 100 plus 44
Mm-hmm.
over
Square root of
2.
144 is 12, so 10 plus or minus 12 over 2.
All right.
And then
All right.
the answers that you
So x equals 10 plus or minus, what'd you say, 12 over 2? Okay, go ahead.
And then it's either 11 or negative 1.
So she says, well, I've got two solutions. X equals 10 plus 2, 12,
Yeah, 12.
which is
over-
22, right over 2, which equals 11. Or x equals what? 10 minus 12? Which
Minus
is
12 is negative 2. Negative 2 divided by 2 is
negative 1, right? Or, if we remembered our factoring toolbox, guys, 11 is a prime number. Robert, is 11 a prime number? What goes into 11? 11 in itself.
Oh yeah.
So it's 11 times negative 1 or negative 11 times 1. And the sum's got to be negative 10. I could have said, oh, look at that, 11. So I could have said, oh, x minus 11 times x plus 1 would give me that. So I could say x minus 11 equals 0. And if that makes that 11. Or x plus 1 equals 0. So that makes that negative 1. Could have done it that way too. Remember back in our factoring days?
Yeah.
Awesome. But you got the same thing, right? That's it right here. That's awesome. Now we're going in team center here. Right? And you guys are over here. All right. So,
It's not a point.
no. We're going to wait for Adama.
She's going up.
Only one at one time. So, for Adama. If she doesn't go back to the game, well, let's see what's going on. Now, I've got you in the center. X squared equals 9x. Galen, can you remind me what the standard form was there again? X, so you said ax squared plus bx plus what? C equals 0. Does that look like that? What are you guys going to do? Are you shaking your head? What are you going to do?
Minus.
Awesome! I couldn't have said it better. So x squared equals 9x. If I subtract 9x from both sides, I get that, right? And that's kind of what I want. Isn't it? Now, can I factor this? What's the very first tool, Ryan, in our factoring toolbox? And is there a greatest common factor?
Yes.
What is it?
X.
Awesome. So I can pull out next then, right? What do I get?
You get x minus 9.
All right. And Christina, how do I solve that? X minus 9 equals 0. Awesome, Adam. So we say, because of the zero product principle, that if either one of these is 0, the whole thing is 0. So we got x equals 0, or x minus 9 equals 0. And you can plus 9 on both sides, right? And I get x equals 9. So I got x equals 0, or x equals 9. Now let's take a look at the one in the center. All right, over here. Come here, help me out. X, I'm going to do yours because you guys are important right here. X squared equals 81. What'd you do to solve that? All right, x squared equals 81. And you did a factor tree, or what'd you do? Oh, so you said 9 times 9 equals, so you said, oh, this is 9 times 9. So I have x squared equals 9 times 9. So what? Jack? Go ahead.
X minus 9, because if you do x times x squared, and then 9 times 9 is 81.
All right, so x squared what? Minus.
X minus.
I like where you're going with that. X squared minus 9 squared, right? Is that where you were going with it? But I think Lauren has another thing. So, Lauren, how did you do it?
I just know the square root.
All right, so you took the square root of both sides? X squared equals 81 square root. So what'd you get? So when I do the square root of x squared, what do I get? X. So that's what Lauren says. She says I got x equals 9. Is that what you got? Is that the correct answer? Who thinks that's the right answer? Is that the complete answer? Ah. Where? No, it's x minus 9 squared.
He's asking if it's just x equals 9.
Oh, here? This is x equals 9. Yeah.
Because the arrow looks like a 7.
Oh, does it? It's an arrow, right. Brian, is that the complete answer? What do you think? What do you think? Right or wrong, doesn't matter. What do you think? Gregory, what do you think? All right, I'm going to ask you as a whole, China, tell me what -9 times -9 equals. 81? But wait, I got 9 here. It's or x equals -9.
What?
Right? Because -9 squared. So when I take the square root, right, of something like that, let's go back here, I've got to be careful to do plus or minus. That's where, like in the quadratic formula. Yes, Samir?
I don't know the right way. You could put x minus 1, you could put x equals 1.
Well, I'm going to go your way in a second and show them. So that way, so in that case, you get, right, x squared equals plus or minus. Because, in this case, it doesn't matter. Negative times negative is a positive, positive times a positive is a positive, so it's plus or minus. Now, what Kamir was doing earlier, he was like, yeah, it looks like something I've seen before. And what do you think, Don? Tell me. X squared minus 9 squared, what does that look like to you? It's a difference of what? Squares. Squares. Brian, what's the formula for a difference of squares? So if I had x squared minus a squared, what would that equal? You guys should know this by Friday, Jack and Gino. What's up? What do you think it is, Dalen? What's x squared minus a squared? Well, if there's a difference of squares, it's going to be x plus a times what do you think?
Oh, you mean?
Yeah, you got your hand up. Tell me.
A squared.
It's x plus a times x minus a. So, Lauren, as we were saying, if I had x minus, make that an a and 9, then it's going to be x plus 9, x, and that goes to 0 when x equals -9 or x equals 9. Same solution, right? The plus and minus. So, bottom line, Jack, when you take the square root like that, you've got to make sure, if you do it both sides, that's fine, but you got to make sure to take the plus or minus on it. So, yes. Almost. Let me get to the punchline. All right. So, punchline's right here if you want to get to our game. Here's our punchline.
Thank you.
Right? So, well, ignore that. We just did that. So.
Wait, I thought we were playing Jeopardy.
There we go. If we are given a standard form quadratic, and Dalen has been kind enough to regale us with what that looks like several times, right? If a and b are greater than 0, then I can factor. Do I need to factor? Yeah, that means, remember that linear term? Right? That x is here. I've got some sort of, for example, I've got 5x squared perfect plus 9x. I can, Lauren, there's a GCF there, right? 5x squared plus 9x. That's not great. And what was that GCF right there? 5x squared plus 9x?
You said Lauren.
X.
Did I say Lauren? Because I'm over there. So Anna. X. Sorry, Lauren. Didn't mean to.
That's why I was.
Didn't mean to denigrate. All right. So yeah. But now look, if the b, that linear term, isn't there, now I'm going one. That's why I was one step ahead. Because your team's over here, right? If I'm not, right, that linear term's not there, then I just got ax squared equals c, right? I can just take the square root of both sides, but make sure I do plus or minus. Now, if that c is a perfect square, I can use the difference of squares, but I don't have to necessarily, right? I don't necessarily have to factor it. I just say, oh, x squared minus 16. I can say x squared equals 16. X is the plus or minus 4, right? Make sure when I take, if I would do this, x squared equals 16, I take the square root, make sure you put plus or minus, so that you get plus or minus 4. All right, so when you see that on the test, Ryan, make sure that that has a plus or minus. So go ahead. We're going to play Jeopardy now. We're going to start without you, but hurry back.
I'm about to drop the deuce.
No. Oh, sorry, I thought you said. All right, so you guys are in your teams. We've got enough time to play a pretty good game here. So your team 3, your team 2, your team 1, team 5.
Team 4.
Team 4, your team 1, right? You guys are 1. Now, the way this is going to work is I'm randomly going to choose a team. That team's going to start with control of the board, Gino. and Jack. And when you know an answer, someone from your team raise your hand. I'm going to be the judge, but if I miss it, I have, just like in the regular studio audience, I have an official scorer over here to my right who will help me determine who raised the hand first. Okay? And I'm going to keep track of all of your points right over here. All right? Let me introduce you to the categories right after I get the scoreboard ready. And then we're going to go for it. Team 1, Team 2, Team 3, Team 4, Team 5. And I'll just cut it that way. All right. That'll have to do. All right, guys. Sorry. All right. Remember, as Alex Trebek said, to phrase your answer in the form of a question. All right, awesome. Here we go. What is it? That's not enough, right? We can do this one. Hold on. So on this one or this one? Close for you. All right. Mine is here. I know that was. All right, hold on, guys. There it is. Hey. We're ready, guys.
There's a block.
Now.
Who you talking about?
All right, guys, let me introduce you to our categories. All right, here we go. Here's Team 1, Team 2, Team 3, Team 4, Team 5. All right. Now, our categories are complex. Adama.
Yes.
Really? Imaginary island. The discriminator. All things quadratic. To factor or not to factor. The tools of the trade. And I will randomly select Team 1 to select. Give me the category. And the amount. Okay, Ryan, just in time. Here are our categories. Okay, what is it going to be? Imaginary island, Jack. Wow, did you hear that? She's going for the throat right away. Imaginary
No!
What do you want?
100.
Oh.
No, she said 5.
I know what I said.
In the quadratic formula, the discriminant is this expression under this.
Stay over there.
Got it.
Yes, Anna.
B squared minus 4A. AC equals 0.
And what's it under?
What?
What's it under?
It's under.
Into the quadratic formula. What's it under?
Hold on.
Wait.
What's it? Just stay with us.
What? You said it. You said it.
Yes. Okay, there it is. We got an answer for 100. What is the radical square root sign? B squared minus 4AC, right under the square root. Your team 4? 4 has 100.
Alright.
And control of the board. Guys, go ahead. Choose. Conundrums. Complex conundrums for how much?
500.
Wow. A plus BI and A minus BI are known as these. No. What's that? Not yet. Go. Yes. Say you went to 500. There might have been a level jump. Yes. That's close, though. That's binomials. I like the answer. The answer is we're going to go in 4. See that? 3, 2, 1.
Expressions.
No.
I tried it.
All right, time's up. What are complex conjugates? Remember when we multiplied A plus B times A minus BI? We only got real.
You're real close.
That's real. Okay, take another one, guys.
Real good answer.
What do you got?
You pick it.
You guys pick anyone. Oh. Oops, sorry.
Push it up.
No, that was me hitting. What happened? Alright, well, I'm going to start your 100 anyway.
It's okay.
That's alright. I don't know what happened there, why it did automatic. No worries. We'll just start back right where we were. That's probably wasn't alright. So, we'll just ignore.
We already did.
We already did a couple of them, so we already did 500 and discriminated to 100. Go ahead. Pick.
Imaginary island.
Did we do that one? No, the imaginary number I represents the square root of this number.
-1.
You got it again.
-1.
Plus 100 is 200. All right. The square root. What is -1? Okay, now you guys have the board. Where is the team here? Give me some. It's a teammate. It's a
I'm gonna do
member.
the same thing.
What do you guys want?
200.
Okay, imaginary island for 200. There it is. I squared is equal to this value, Robert.
-1.
All right, I gotta give it to the team.
you-
Yeah,
1, 2,
bro.
3.
Wait, should you
Pull it
do
in.
the ones that we already did too? Like,
So that's 200.
So what? They just tied it.
What is -1? You're bored, guys.
It's
Alex,
more.
300.
Samaya,
300.
pick a category.
300.
300.
Oh, blah.
Of what?
Imagine that.
Oh, he likes it. He gets it. He likes it. I plus I equals this value. Lauren was the first.
No, she was not.
I squared.
That's the main
No.
one.
Damien. No, you got the clock now.
Ooh, me.
You can't get your eye.
Look.
No.
I'm good. I'm just
One. I would have back in the back.
No.
Go. You're next. What is it?
I squared.
I squared. No.
No, I'm right here.
No.
One. Hey, pick up.
Oh, over here. What's it? I plus I equals.
Oh, I squared.
No.
-I. -I.
No.
What's I?
2I.
What?
I plus I is 2I.
No.
Combine like terms.
Wait.
so many numbers.
That's all right. No worries. He's over here. You guys give me another category.
400.
400. All right. According to the circle of I, the frequency with which the value of I raised to a power of itself repeats itself. How often, let me rephrase, how often does it repeat itself?
4.
4. I gotta give it to her.
That's a full
Right there. Sorry, team 1. It was just where I was. Sorry, I'll be looking back there for you, Gina. Go ahead.
-100.
That was awesome, Lauren. 4. Okay, no.
500. We want 500.
For 100? 200. Wow, we're jumping up. X squared equals 4x may be factored as this. You might want to write it down to help you with it. Adam, we're playing. All right. Samaya.
2.
Turn it on. Thanks. We're going to come up and we're playing. We're having fun here. Yes.
2x and then parentheses x plus 2.
So I was just saying, so I just want it to be, you were saying what? X squared, it's not quite
2x.
2x, it's not quite
X equals 4.
right, because the x isn't squared. So that should be, okay, yes, Lauren. Plus or minus 2, it's not quite right yet either, right? Because it's okay. Well, you already go.
Wait, what?
You guys already went.
I can go again if no one else is
Well,
ready.
I gotta,
Wait.
No, back there, Dalen. Write it down, piece of paper, quick. Quick, what do you got? No, we're almost done. Okay, all right, go ahead.
You still beat X?
No, almost, go ahead then.
4-0.
X and 2 plus 4.
X times what?
2 plus 4.
Oh, not quite. No, it's x squared there. What do you guys got?
4-0.
3.
I don't understand.
All right, let me show you.
Oh.
It's at 0.
It's because of that stupid 2. Is
X times x squared is 4. Did you? You should have said it. Didn't you?
I just said the answer.
All right, who had the board? Lauren did, right?
Yeah.
All right, so you see what we did there? We looked for the GCF line. We pulled out the X. All right, Anna? That was good work. Go ahead. Give me another one over there. To factor, how much? 100. to factor or not to factor? The value of x when x squared equals a squared. That was kind of your question over there. Michaela, the value of x when a, yes, Damien. X equals. X equals a. No.
1.
All right.
2.
All right, Hannah.
X squared
Oh, that's
equals a squared.
no, but that's not quite right. Anybody? It's going to be going up. X equals, when I take the square root, what do I have to do over here, team 1? When I take the square root, if I have x squared equals a squared, and I take the square root, what do I have to put in front of it? Plus or minus, so x is plus or minus a. All right, plus or minus. Plus or minus.
This is hard.
Okay, go ahead, you got the board. What do you got? Come here, tell me.
Tools of trade 200.
Tools of the trade for 100?
200.
200. The GCF of 8x squared y cubed and 16x cubed y fourth is this. The GCF, think about what a GCF. Gino.
So the first one would be the 8x to the second, y to the third would be on the outside, right?
There. I'm going to just stop you there because if I see the answer, he's got it.
What?
That is the GCF for those two terms. That was the greatest common factor of those terms. Gino, what team are you? 5? What are you? 4? 5. 4? You're 5. You're 5. But that was a good one. You got 200. Team 5, 200, and you get control of the board, Gino, more importantly. Go for it. Factor.
Imaginary island 500.
Oh, he's going for it. 500.
He's going big.
I to the 15th equals this value.
Go ahead.
-1. No.
Wait, what? We didn't.
Negative I. Damien says negative I. Negative I. Nice job, Damien. All right, that's team 4. That was for 500.
That was a good game.
Come here, son.
700. Team 4 has 700. And Damien, you have control of the
That's
board.
-1, not negative I. That's a -1.
All right, go ahead, Damien. Pick one. Remember, I want. So the odd numbers have to be
Wait.
Go ahead, Damien.
Stop funny.
That's what he
It's
said.
a negative I.
Yeah, that's what he said. Nice job, though. Okay, Damien, guys, give me the board. Tell me. The discriminator for 300, you said? The discriminator.
I don't know, negative.
The number of distinct solutions or roots to a quadratic equation when the discriminant equals 0. Yes. Wrong. No. Who's going to go? Quick. 1. Team 4. Yes. How much? 300? You're at 1,000.
What is it?
Remember, the discriminant goes away to 0. Yes, Greg.
1.
What's that? Because that square root goes away, so there's no plus or minus. It's just x over whatever, x equals negative b plus or minus. That part's gone. It's just negative b over 2a. There's our vertex, right? All right. All right, guys. You guys now have control of the boards. Let's have it. Pick one. What do you got?
Tools of trade 100.
100. Tools of the trade. When factoring, this is the first thing to look for. Boy, that came on the first one. GCF is 100. Is correct. All right, you have control of the board.
That goes to team 5. That goes to
What are you
team
going to go
5.
for?
That's team 5.
Tools of the trade 500.
500. Going for it. The quadratic formula equals this.
Oh, yo,
Ed was up first, bud.
Go
Ed was
ahead.
up first.
I was
You looking over there all the time.
Plus or minus the square root of b squared.
I was definitely
minus
first.
Yeah, bro.
4ac
Don't look
over
over here.
2a.
I think she had you by like a split.
Nah, you
second.
No, I was
nah, you
100%.
don't- That's because you looking at where you cheat. Yeah, you
I didn't cheat.
I demand the room over here.
I I honestly like.
You honest?
I honestly.
All right. Who saw it over here?
I saw it.
I saw it.
We saw.
We was first.
All right. You know what I'm going to do? I'm going to
He's
call
on
it
my
time.
team.
I'll give you both the answer. What is it? No, you have to tell me.
Okay. X equals negative b plus or minus, then square root b squared minus 4ac over 2a.
All right. I'll give it to both of you. Team.
We gotta do that.
Team 2?
Four.
We got it
and
too.
1.
5
All right. But I'm
two.
going to keep control over at Team 1, which is fair. And Team 4 has 1,500 now. Go ahead, Team 1. You have control of the board. There you go. There it is. Go ahead. 300. All things quadratic. Awesome. Okay. The standard form of a quadratic neighborhood. Oh, Daniel was first. I got to give it to you.
Okay. AX squared plus B squared plus C.
Oh, you said a little while Gregory was next. What is it?
Take it for.
Saying way too long.
You ready? You got it? Go.
Oh.
Yeah.
Yeah.
Okay. AX squared plus BX plus C.
Yeah. It would be x squared, Dan.
I know,
So,
man.
what was that value?
700.
Wait, what team are we on?
There it is.
Oh, it was 300. 3? Yeah, it was
300.
400.
All right, what's the
We had
next?
200.
So I got 1,300.
No, we
No,
team
no,
4.
no.
No, we team 4. We team 4.
Sorry, 1,800.
We
Sorry.
started like that.
So I got 1,800.
Okay.
We're gonna play first one to 2,000 because we got to review here. So first one to 2,000. Okay, go guys.
500.
Quadratic 200.
200. All things quadratic for 200. The two primary forms of the quadratic equation are this. You.
Standard and vertex.
There it is. Standard and vertex.
Down.
All right. So we got
Hey,
down
came
to our
second.
Jeopardy
200.
champions right there at 2,000. Nice job,
Yeah,
guys.
we got
Although
extra
over
credit.
here, these guys are awesome.
We got extra credit, right?
I'll talk to the official scorekeeper. However, now,
Give us a chance.
Oh, damn.
all right, guys. So,
That's team 2 right there.
so slide two. There we go. So, to review, the discriminant of the quadratic formula is this. Don't put it away, you got a question. This is b squared minus 4ac. Gino, what's the discriminant?
B squared minus 4.
Robert, what's the discriminant? You can look on the slide.
Square minus 8, 4, 8.
Damien, what's the
equals
discriminant?
0. What's funny?
Come here, when you take the test, what are you going to tell me? B, what's the discriminant? B squared minus 4ac. The value with D determines the types and number of roots that you get. If it's 0, right? If it's, greater than 0, you'll get 2 real roots. Remember that square root? Now it's positive, so I get plus or minus some real number, right? If it's less than 0, as Adam say, Gregory, almost done, we get that I, right? So we have plus or minus some sort of I, so we get 2 imaginary or complex solutions. And, Gregory, oh, you did pictures? Oh, cool, go ahead. And then D equals 0 gives me, it gets rid of that square root. So I only have 1 real root. To find the roots of AX, right? If I see something like that, I want to take that C and put it on the other side and give it a standard form, right? If both A and B are greater than 0, I can factor to find the roots. If there's no linear term, I can do x squared equals C over A, but you gotta remember to put a plus and minus, right? All right, there it is, plus and minus square root of C by C over A. And we got one thing now, it's time for your exits. Exit slips. Take out a piece of paper, everybody. You won.
No, I don't.
Take out a piece of paper. You don't need to do it. Take out a piece of paper.
Split it in half.
And I want you to do this. Minus 7x plus
Oh.
set that equal to 0. What are the number and type of roots?
Are the number?
What are Number and type of roots justify your answer.
I don't even understand what that means.
Yeah, I mean it's got, yes, it's 5x squared minus 7x plus 6. So the type and number of roots are this. Justify your answer.
What are
What's
the
your
numbers?
name on it?
Mr. Walmart, can you please explain? Just give me a
Yeah,
zero.
you have to tell me what the types of roots are. What kinds
Type
of
the
roots?
types.
Yeah, is it real, imaginary, or and how many? We spent half the class going over
Is
that.
that a 7 or
Right?
a 1?
Yeah, you remember that when we had 3 boards going?
No.
Yeah. That's what I'm here to know. To see if who was. I don't think were you paying attention, my friend?
I was.
Oh, let's put it down. Then I want to see your name on the paper. All right,
Is that a
guys.
7?
The number and type of roots
No, is
are
that
this and justify. Yes, 5x squared minus 7x. I think I believe 7. Plus 6 equals 0. What are the number and type of roots? Justify your answer. I didn't ask what they were. I just want to know how many of them are there and what type are they and why. But you can do it. You can figure out what they are. That gives you the answer too. You don't have to tell me, but that's a good justification. Well, what determines the type and number of roots? And what do we call that value, Jack, that determines whether the types of roots? Yes, Gino? No, what's the type? What determines it? Think Arnold Schwarzenegger.
I'm done.
The discriminant. So I'm asking you to determine that. That's what I want to know.
I
Right?
don't know. I have no idea.
You didn't see the slides with Arnold Schwarzenegger?
I didn't understand that.
Well, you will, because he's going to go over it.
It's no real numbers because the number inside the thing is walk through the problem.
Where's your thing?
When I did,
Why don't you do
Oh, here, you gave me the wrong one. This is it right here.
oh, sorry.
I got it.
When I do 7.
Where's your third? Take a guess. Everybody, I want everybody's guess.
No, no.
I misspelled imaginary bomb. What do you mean? He said.
Oh, this is
How
the
many?
Wait,
Yeah, the third in there.
who's cinema?
Yeah, I'm sure you do. Yeah, right here. So, what's that tell you? Yeah, discrimination. Make sure I get it. Kayla, where's your sheet? Right there, you have it. No, you can tell me.
What you got to say? What you got to say?
I'm talking right on.
So how many minutes do you have? No, it's 66. See you all later. It's going to be plus or minus. Two, but and what do we call those? Begins with an I.
It has 3 numbers.
Oh, there we go.
Oh, you guys think I can do it?
Yeah. Awesome. Awesome. So
Yeah, Jake's pleasure meeting.
So remember, the discriminant, you're going to get this 1,000%. 1,000 is plus or minus, right? It's p squared minus 4ac. This is the discriminant. If it's positive, right? You're going to get what? You're going to get plus or minus some real number. So it's going to give you 2 real solutions. If it's 0, it goes away, and you only get the negative b, and if it's negative, you get 2.
That doesn't matter.
Yes. What's that? So what are the number and type of roots?
Hello, what are you doing?
Well, I would say that
Come on in. We'll be with you in a few moments. We will be right with you. Hello, what are you doing? Is he going over to the top? Nice. Love to hear it. Hello, how are you? What we're doing, we've got tests coming up. 2 of them this week. One on Thursday and one on Monday. So that's going to help, okay?
If it's 0,
So if you want to prepare for those, you can help you today.
Oh, I can't do today. I swim, but
So that's why
tomorrow.
Yeah, just make sure you stay one of those days because we got, I'm going to talk to you about it
I don't know.
We got one on Thursday and then one on Monday. Okay? So we'll give you the details tomorrow. All right? What's up, dude?
I will not be able to say today.
Oh!
My wrestling.
I have no